2.3.3 represent proportional relationships by equations given a scenario in order to predict future values. So a traffic jam has slowed down the traffic on the highway. After 1/2 hour, cars have only traveled 15 miles. So 1/2 hour, right? 15 miles. That's the relationship. Using t for time, so t equals time, and d for distance, write a direct variation equation to represent this scenario. Also, if the traffic stays at the same rate, how far will the cars have traveled after 1.5 hours? Okay, so we know that distance equals rate times time. This is similar to our concept of y equals k times x. Okay, this is similar to that. You can see the relationship. Y is d, r is k, t is x. So here we know that the time is a half hour. So let's see. So the time is 1/2, and that's times, we don't know the rate, so r, but it's equal to the distance, 15. Okay, so 15 equals r times 1/2. So that means we need to divide by 1/2 or multiply by 2, right? So we're going to multiply this side, so equal sign highway, we're going to multiply by 2 because the reciprocal of 1/2 is 2. So we're going to multiply this by 2 because 1/2 times 2 is just 1. So we can say r equals 30. Hey, so we know our k value or our r value. So d equals 30 times t. So that's the equation here. D equals 30 t, or 30 times t. What's the distance after 1.5 hours? Okay, so what is the distance after we know the time? 1.5 or 1.5. And d equals 30 times 1.5. So 1 of 30 is 30. Half of 30 is 15. So 30 plus 15, okay, equals 45. So the distance is 45 what? 45 miles.